All right, so today we're going to talk about classes. Finally, I say. Classes are an abstract term in programming, a little more theoretical than what you're used to so far. So if you had trouble understanding arrays, you might have trouble understanding classes. They're a little more abstract. But they're used in almost every language, every modern language, every one of the newer languages. The older languages don't have these. They're built, they're new, based on the object-oriented paradigm that we started when C++, I guess, was probably the first major one that had that. And C# has classes, Ruby has classes, Python, JavaScript does not, but they can make pseudo classes. They kind of work around using a prototype environment if anybody's in the JavaScript class. And PHP also has classes, but we didn't use those except we didn't use those in PHP. So the idea of a class, we've been using them all along. The idea of a class is just a template or a blueprint for defining data objects and the methods that can operate on that data. So that's the definition of it. The idea of a class is to group things together into one unit so that we can have access to them. So if we have something like strings, that's a built-in class. So last quarter I always asked you what type of variable this was. Where did it come from? What class is it? It comes from the string class. The string class had all kinds of stringy things you could do with it, right? I would always say that. You could go to the class documentation for a string, and you see there's a 2s, there's a 2i, there's a 2f, there's a split, there's all kinds of methods associated with that particular object, that string object. So what they did was they grouped all of those methods together into a class so that they could keep those together. So the data in the class is the string itself. Whatever that string is that we're going to manipulate, that's the object that comes from this string class. So when we create a new string, when we put quotes around something, that creates a new string that gets all of its properties from the string class. And those properties are the data itself, what makes up the string, as well as all the methods that can operate on that object. So this is all an object-oriented system. All right. So we have a lot of built-in classes that come with the Ruby language, and you're familiar with them already. You've used them, just not in the term of a class. So we have a fixed num, we have the numeric class, float class, an array class, a hash class. So when I created an object from the hash class, it was the data that was associated with that hash is the object, and then it has a bunch of methods that I can do on that object, right? And so that all comes from this blueprint of the hash class. All right, so there's a lot of terminology here. The big computer sciencey term that we use for this is called encapsulation. So if you want to Google that, encapsulation is something that might be an interview question. You know, what is encapsulation? The idea of encapsulation is to put everything together in one area so that I can manipulate it as a single object. So a string has its data, but it also has all those methods. So I've encapsulated all the properties that deal with a string into one class, into one place that I can move around. So when I copy a string from one place to another, not only does the data part of the string come, but its methods associated with that come with it. So it has all these properties associated with it. So it'll become a little more clear. Every time we create something, it becomes an object. And that's what we talk about object-oriented programming. An object is just a thing that came from a class or a blueprint. So, for instance, if I take this into the real world, say my cup, this is an object that was created from a blueprint. Somebody had a computer model about this cup, and they put it into the computer, and they pressed out some steel and put some insulation, made a cap for it, and this became an object that came from a blueprint that somebody had. And they can stamp out 1 million of these, and they all look the same, right? This is an object from the cup class. Okay, this came from the cup class, and as because of that, it has some properties. It can hold liquid. It has a cap that I can screw on and off, and it has all of these cups come from the same place, right? But I might put coffee in my cup, and you might put milk in your cup, and you might put Jack Daniels in another cup, right? So you're going to have different stuff that you store in the object that was created from that class, that cup class. Does that make sense? In the real world kind of a way, everything is an object. My mouse is an object. My keyboard is an object. They all got stamped out of a blueprint that created mice and created keyboards, etc. But they all have a little different qualities. Once they're created, they can do different things. You know, they can hold different stuff, things like that. So when we create objects, we're trying to create real-world representations of things in the computer. And the class metaphor helps us do that. So it's just a piece of data. An object is just a piece of data that's been created from that. So anytime we have something like hello string, that's an object from the string class. So whenever I ask you now what class this comes from, you should be able to tell me what data these things come from. All right? So if I give you something like this, you should instantly be able to say, well, that's the syntax for creating a hash, so that is a hash object from the hash class. Okay, a lot of terminology there, but it makes you understand the differences. This hash, this particular object that was created, could be something different than an object that you guys create. You're going to have different objects, different strings, but they all have the same blueprint that created them. They all have the same methods that I can do on a hash. I can do hashy type stuff with them. I can do stringy type stuff with my strings. All right? So we think of classes as defining the state and the behavior. So the state, what do you think the state would be in a string class? State is kind of an obscure term. I mean, it's a theoretical term. How about behavior? Let's skip state for a minute. What do you think behavior means? The methods, very good. What I can do with that object, how it operates, how it lives in my computer. Behavior is what I can do with that thing. It's the verbs that I can associate with the data in that object. So the state is the data itself, what that data is. So we only have data and we have methods, or we have state and we have behaviors. Okay, so in a more abstract term. So let's take an example of a square class. So this is something, it's not a string, it's not a hash, it's not an array, it's a square. And we try to represent what properties does a square have in a computer. Okay? So let's try to think about, let's move that off to the side, and let's think of a square. Let's just think about what attributes does a square have. You guys remember your geometry? Okay, it's got 4 sides, and they're the same length. Okay, what else? You think that's it? It's got 4 corners made up by the 4 sides. So the 4 sides are the same length. So how might we represent a square in the computer? With what you know now, forget classes, how would you represent a square in the computer? Wow, I'm a square. Wow, that's nice. That's I haven't heard that Long time. Yeah.
It would be 490-degree angles.
Right, it would have angles associated with it, maybe. Okay, 90 degree, they're all the same. Let's just write that down. 90 degree angles.
Yeah, but aren't those all properties as well?
Right, these are all properties of what a square is. Right, absolutely. We're trying to represent what that is. So, based on all the stuff you know in Ruby so far, how would you represent a square? All right, we did that, right? We did that puts. Remember the last quarter we drew a square using the asterisk, and we drew it down the screen. So there's a representation of that. There's a printed representation of the square. Very good. Only Ken would do that. So how would I represent a square? Would I have an array? I mean, what would I use as a square? How would I represent that?
Probably a block of code.
Okay, a block of code. But what type of data representation would I use to store that square? A string. Okay, maybe. An int. What would the int represent?
Well, for the sides and your degree of angles, you need that.
All right, so I might have my sides, side length.
I would say a method would be
All right, so I might have a method. So let's define a square. And what is that going to have in it? Okay, it might draw, but
you would need to get some kind of user input to determine the length of the sides.
okay, so I need the length of the sides in my square somehow.
Don't you have just trying to define what a square is, all that stuff on top is basically.
Right, how do I fit that into the data that you know? You have strings, you got arrays, you got hashes.
You slap it together and
Right, it doesn't fit with something that we already have because it has too much information. I can't just say I have an array of squares. It doesn't. What does a square mean? I haven't really defined that yet. So it's a little difficult to put into just a simple string or a simple hash or an array. So that's where we come up with these classes. And a class lets us combine all of this stuff together into a nice little package. We've encapsulated the data associated with the square, which is what? What would the data of a square be? The length, right? That's really the only thing I need to define a square is the length of the square side, of one of the sides. Because from that, I can get the length of all the other sides. Since it's square, by definition, I only need one data point. But then I need some other stuff to operate on that stuff. I need some methods or to define the behavior of how a square works, right? So a square has some things like I want to be able to draw the square. I want to be able to print out some properties of the square, things like that. So to do that, we have this concept of a class. So let's put all of this stuff in a block here. And let's talk about some new syntax. So in Ruby, we define a class like we define a method with the word class. And that's a keyword in Ruby, which is why you couldn't use that for the first assignment in Ruby. Remember the class, some of you had to spell it with a K, for instance, or you used a different variable name because class doesn't work. It's a keyword like if or else. You can't use it for variable names. And then we define our classes with a capital letter, and this is required to differentiate a class from just a simple method, which is why we don't make our methods have capital letters in them. So we might call it a square with a capital letter. All right? So we define that, and then inside of this, these two statements, the class and the name of the object or the name of the class and the end, we can put all kinds of stuff in here. We can put our behavior and our data and store all of that stuff in here. All right? So the first method for almost every class, we can combine, we can have as many methods as we want inside of a class. So how do we define a method? You remember how to do methods from last quarter? Def, right? We do a def. And the first method in a class is its initialize method. And again, that's a keyword method name that we're going to use to define the creation of a square. So we use the word initialize. And one of the biggest issues with programming this is spelling initialize right. Too often you say, well, my class doesn't work. Well, you spelled initialized wrong. Yeah. IntelliSense helps you on this, right? So initialized lets us set certain properties of this square. All right? And we can pass in, what's the data that we need to create a square? The side length, okay? So we can pass in the side length, and we call it side length. All right? And we can do something then with that variable inside of this method when we create this side length.
You'd have to prompt for the
Right.
side length.
And that brings us to the point, and you'll hear me do this the rest of the quarter. We almost never do any user input inside of a class. We do that outside of the class. Okay? We don't do puts inside of a class. We don't do gets inside of a class. And the reason we don't do that is that we don't know who's going to be using our object. And we don't want to tie them down to the console. We might create this square class, and we might want to use it in Rails, and the output in Rails is what? Anybody know? What am I outputting in Rails? The answer, we're outputting a web page. Okay, so we're not doing puts. We're outputting HTML, and it becomes different. So we don't ever. Yeah, exactly. Right. It could be a JPEG. It could be anything. So anyway. All right. So in order to store the state in this square class, I have to save this side length into some variable type. And we're introducing a new variable type here called an instance variable. Okay? An instance variable is something that is local only to the entire class. Okay? It's not available outside the class. And this is part of the encapsulation. There's a lot of computer sciencey terms here. But we're trying to keep together the state or the data and its behavior or its methods all together into one little object that I can move around. All right? So we differentiate instance variables by using the letter, the @ sign. The @ sign. So @ and then we can call it the same as any other Ruby variable, all lowercase, typically underscores between things. So I might call it side length. And I want to store into it whatever they pass into the creation of my square method here. All right, so that's saving state with this class object. So let's go and try to create an object from this square and see what we can do with it. How did we create a new object from the string class? How do you do that? We just said something like this. This is a string. Because it's used so often, that's a shortcut for what's really going on behind the scenes. What this is doing is I'm calling the string.new method, and I'm passing it in some data. That's the same thing as just saying A equals that quoted string. All right? How would I create a new integer? It would be a 10, right? That's a shortcut for saying I want a new integer of the integer class, and I want to establish the data for that as a 10. So that's exactly the same thing. I should be able to say puts A and puts I, and let's run this. Oh, doesn't like that. Really? That's interesting. Um,
Maybe it's because you got the equal.
no, that's interesting.
Depends on
Because he's doing it two different ways. He's doing it the shortcut way and
where
Huh. Maybe it doesn't let you do it this way. I thought for sure it would. Well, yeah, I'd like the string. Let's see if that works. To invalidate everything. See, it doesn't like that either. Oh, well. Duh. Well, that's interesting. I'll have to figure out why it doesn't like the new for that. But that's basically, essentially, what's going on behind this scenes, okay? So if I want to create a new square object, I would say my square, I might call it square, is, or I'll call it my square. People like to do my square equals the square. And notice how RubyMine already knows that it's a class. See this C here? It knows that it's a class because I defined it. I can call .new, and I can pass it how big I want my square to be. All right? And so then I can say, let's print out my square. Let's see what happens. All right? So when I print out my square, it doesn't know how to print out a square. That's not a normal object. Whereas if I say puts the string, it knows how to print out a string to the screen. It knows what that is. It's built in to the Ruby language. But a square is not. I just added that to the language. It now has a new entity that it needs to deal with. So the best it can do is to print out the type of the object it is here. It's a square from the square class. And this is its place. I like to think of it as its place in memory. This is a location or a unique ID for this object in memory. It's a hexadecimal number, which you guys should all be able to translate in your heads back to a decimal, right? Right, that's probably 42, right? No, definitely not. So, do you guys remember what 42 is in hex? It's 2A, which is the same thing as
if I had the key, I would.
that. See, you should just know those by heart. All right, anyway, so so my square here has, this is the only way it knows how to print this out. All right, if I try to print the .inspect on it, I get a little bit more information. The inspect method gives me, what? Insect. You do have to spell things correctly. That's very important. All right, so if I printed the inspect, I get a little more information. I get that it comes from a square class, its unique ID in memory, and the instance variable and what it was set to. So I know that this particular my square has data associated with it of a 10 for its side length. Now, if I created a second square, we'll call it your square. Now, and tried to print out your square .inspect. Oops. I'm going to get different information. Each one is a different object. It's a different cup that was stamped out from the same blueprint of the class square. Okay, so they all have the same properties associated with it, but each one might have a different color, like my cup is a different color than yours. This one is, the side length is different from these two objects that I just created. So my square has 10, and your square has 20 for the side length, and you see that here when we try to inspect it. Everybody see that so far? It doesn't, well, let's do that. If I change this to 10, I get the same property of side length, but the address is different in memory. They are indeed different objects. Okay, they're completely different things, and I can manipulate them as two separate objects or two separate cups in my hand. I can maneuver them around. I can save them. I can have arrays of these squares, and it's just another object like a string now. I can maneuver them around and play with them, change them, etc. All right. Any questions on this? Very intro level to classes. Now your book has some information, and they go through. I think they create the person class and things like that. And we'll do more of this. We'll play with the square some more tomorrow. How to manipulate that. How to add some more behaviors to our square so that it can do something rather than just sit there and hold a number. Right now, that's all it does. It holds a number. All right. Any questions? A little more abstract, but this is where we're going. You've got to get this down. So, all right, that's enough for today. I think your brains are hurt.